Hey everybody, happy Friday. Welcome to TGIK number 148. So psyched to see you all. Looks like we've got Steve, Waleed, Martin, Rory, Sevi all joining us as usual. Thanks so much for joining today. Glad to see you all. All right, so today we're talking a little bit about gateway APIs inside of Kubernetes. Some new stuff that's kind of coming down the pipeline out of SIG networking. And things that we're going to start to see ingress controllers like Contour, and I'd imagine Nginx, Traffic, and others start to implement. So psyched to check this out with you as always. If it's your first time joining us for TGIK, it's kind of tradition if you feel comfortable to say hey in chat and where you're logging in from. But what we typically do in these episodes is we go through some topic inside of Kubernetes land and we just kind of explore it together. Sometimes we know a little bit about the topic, but most commonly, like today, it's new to us as well, which for me, gateways and the implementation of gateways is completely new. So I'm really looking forward to learning it with you all today. So let's see who we've got joining us so far. Like we said, Steve, Waleed, Martin, Rory, Sevi, we've got you as usual. Thanks for joining. Rodolfo from Austin, thanks for coming back. Luke, hey Luke. Yeah, I'm in Colorado as well. I'm waiting for the snowpocalypse to hit us here. Eric, great to see you. Eric, as always, hope you're doing well. Ivan, great to see you. Steve is in from the Contour team, so he's a little bit closer to these gateway APIs, and by a little bit, I mean a lot. So as we mess around with implementing these or using a controller that implements them, he'll be here for backup. So thanks for joining us as always, Steve. We've got Tim joining us again. Hey, Tim. Elko from Holland. Steve, yeah, new location. I'm still in Boulder, but I'm in a different place, just moved in. That's why you see a bunch of junk behind me, but I'm slowly getting my stuff together here. Maddie, thanks for joining us, Maddie. It's great to see you. Yusuf, great to see you as well. Rajanche, great to see you again. We got Marcin from Poland. Welcome. KR from Scotland. Philip from Germany. Hey, Philip. All right. Eric says it's 80 degrees in DFW today. Yeah, we had great weather in Colorado the last couple days. It was like 70 degrees almost, but we're due for some snow and some cold. It's been a pretty easy winter for us this year, so I'm sure it's coming soon. Ismail, great to have you. Anos Ansao from Paris, great to see you. Smee from Tunisia. We've got Leah. Hey, how's it going? Richard from Austin. Hey, Richard. Irby from London, or Irby. Hey, Kashrao, nice to see you again. No, it's not a box of climbing gear. That's in a different room. And that room is way more messy, so I'd be embarrassed to show you all that. All right, so thanks so much for joining us today. Let's get into the news for the week as usual. You can find this at tgik.io/notes if you're interested. We have a bit of a light news week, mostly because I'm not up to date with the news. But I did have some folks put in some good stuff. If you have anything else you want to share, feel free to add it. Kubernetes 1.21 will be built with Go 1.16.1. So pretty exciting stuff. I don't really know how hard or easy this transition was. I think there were some like weird bugs and stuff that it brought up in switching the Go versions, but at least to 1.16 that is. But I'm glad to see that we're already staying on top of the newest patch release in Golang, specifically the security update that they put out. And Go 1.16 is great, right? It's got some new features in it, unlike most Go releases. So I'm looking forward to checking those out. 1.16 is where they put in the static file stuff, right? Where you can actually like build with static files just out of standard library. I can't remember. And we've got generics coming and all these different things in Go. So it's an interesting time to be a Go programmer, huh? Pretty cool stuff. Also, there's a garbage truck pulling up right now, so hopefully it's not too loud for y'all. Okay, so Go is being built with 1.16. Kubernetes 1.21 code freeze is in effect this week. So if you are a contributor and you're working on Kubernetes stuff, do note that code freeze is coming up for 1.21. Pretty exciting stuff. All right. Additionally, if any of you happen to work in like some SIGs or some larger repos in the Kubernetes ecosystem, there is now documentation for migrating from a master branch to a main branch. It talks about a lot of the different stuff that you can do from like a prow perspective, make sure your PR volume's low, all these different kinds of things. A lot of times the hardest part is not so much the changing of the name, but it's all the tentacles we have in our projects, right, that depend and reference on all these different things. So it's super, super cool to see that some work has been done to lay out how we can switch over from a Kubernetes perspective. So Nikita and Bob, thanks so much for putting this together, and anyone else who contributed. This is really, really great stuff. Piotr from Poland, hey, cool Sportiva jacket, thank you. Yes, yes, I'm always rocking Sportiva stuff for some reason. Cool. Dennis, hey Dennis, great to see you too. Thanks for joining us today. All right, I think that's all I've got for the core news right now. We do have some stuff going on in the ecosystem. So if you are interested, the Tanzu developer portal has a new post on Contour that talks a little bit about ingress and beyond. So this probably goes over the ingress CRDs, something that we'll be talking a little bit about today. I'm guessing this post is not as bleeding edge as TGIK is. So today we're going to be jumping into like brand new APIs that are being designed and talked about in an alpha, right? But if you do want like a more structured approach to Contour rather than the chaos that I'll be taking you all through, the Tanzu developer portal has a guide up here for how to concretely do some cool routing stuff with Contour and its APIs. All right. Thanks whoever added this. PSP deprecation replacement proposal has been posted. I have not looked at this. So this has been something that I feel like we've been talking about forever. I mean, can you all remember when we started talking about PSP deprecation and then we like maybe weren't going to deprecate it, but then we probably were going to deprecate it, but then maybe we weren't going to deprecate it? Well, it sounds like it's actually going to happen. So if you do use PSPs in your cluster, do take a look at what's going on with the security proposal. I got to do my homework here in regards to how we're going to approach pod security policy like functionality going forward. So really looks super, super interesting. I think my biggest hope, I don't know about y'all going into PSP spaces, PSPs were great, and they did a lot of the checks we needed to do. I think, at least for me, as someone who I think sort of understood them, I think the UX around them was kind of hard. So I'll be super interested to see like what we implement in their place, how we approach it. You know, a lot of folks have been plugging in Gatekeeper and things like that for this type of work. But even that can have some problems. Like, Gatekeeper does stuff at the API validation layer. So where PSPs could do deeper resolution, like an example we've run into before in TGIK is like, if you do it at the admission control layer and you don't declare what user is going to run your pod, then it could fail thinking or assuming you're running as root. But in reality, the pod might default or container might default to run as a different user, right? So there's always kind of this discrepancy between how things could happen at that layer relative to like the conventional PSP layer. So check this out, and maybe on a future TGIK, we'll be checking out some interesting stuff regarding PSP replacement. That would make a really interesting episode, I think. So Steve says OPA will take over. That seems to be the direction for sure. Cool. All right. So let's see what we got going on here. We've got the PSP deprecation proposal. Thanks, whoever grabbed that. We have got container signing verification and storage in an OCI registry. Interesting. Let's check this out. Cosign. Cool. All right. So container signing, verification, and storage, right? This has been something that has been a hot topic for a lot of us for a while. I feel like a lot of times we have aspirations to do kind of this signing and validation, but it oftentimes kind of falls to the side in our backlog. So it looks like Cosign is a project that is doing some of these bits. I have not personally looked at Cosign. I don't know if any of you all have used it or tried it. I'd be super curious. You can tell us in chat how what your first impressions are. But it looks pretty cool at a high level. Looks like you can sign and then push that up to a container registry. So a consistent way to do this would be really, really nice. I think it's something that we've been struggling with for a while. So cool. Maddie says OPA and Conf test. Do you mean Conf test, Maddie? I'm guessing so. Conf test for the win. I love Conf test as well. It's great. We did do an episode on OPA and some Conf test stuff too, everyone, if you haven't checked it out yet. So do be sure to check it out. KR, the link to the TGI Kate's notes is tgik.io/notes. If you want to check them out or add anything to them, feel free. Steve says, Cosign is epic, and I've been messing with it this week. Oh, that's a rave review, Steve. Cool. So I'll have to give Cosign a check. It'll be really cool. Probably check it out next week sometime. Cool. All right. Okay, so we looked at Cosign a little bit. IstioCon recordings are out. I didn't even know there was an IstioCon. I'm so sorry. There's so many cons nowadays. How do you keep track of all of them? This is really cool, though. So we've obviously covered Istio and other service meshes inside of TGIK in the past. You can check some of those out, but it looks like IstioCon did some seemingly really interesting episodes. So be sure to check out the recordings. Very, very cool. Sketch Mesh, Enterprise Support, Envoy hears you when Istio speaks. What Envoy hears when Istio speaks. That's pretty cool. This would be an interesting thing to understand, right? When the control plane is sending out signals to program Envoy, I'm guessing, which is what this talk is about, what kind of signals does Envoy get, and how does that translate into eventual configuration, or in Envoy's case, probably API calls, right? So very cool. Alex, hey Josh, are you deploying the contour operator today? I might be. I'm not sure. I'll see. I might do the contour operator. I might do normal contour. If there's anything wrong with doing the contour operator, Alex, let me know. I haven't even gotten that far in the thought process yet, to be honest with you. Steve says he calls it CRD-Con. Yeah, I like that. We should have a CRD-Con, and it's like everyone who publishes CRDs, we have this kind of universal con for all the service meshes and ingress controllers and CSI drivers and all that kind of stuff. Eric says should be called "You're Killing Me Smalls Con." That would work too. I would attend, Eric, if you want to get that started up. Cool. KR, you said, do we really need network policies when we have Istio authorization policies? It's a really good question, KR. It's something that kind of happens on, I guess, on different layers in a way. Like if you think about like layer 3, layer 4 network policy, some folks do think on that level, it's something that they want to kind of enforce at the CNI plugin, which is the thing actually doing like the pure routing of packets and setting up routing tables and all that kind of stuff. But it is fair to feel somewhat redundant when you look at some of the approaches you can do with, like, for example, even just mutual TLS in a lot of these service meshes, right? So if you don't have mutual TLS between endpoint A and endpoint B, you already do have some level of protection between communication, but it's happening kind of at a different layer. So, I think of that kind of question as almost like a networking / defense in depth type question. And most like folks that I've worked with Kubernetes at large scale, it's just been like, what level and layers do we need to protect at? And sometimes the answer is both. Sometimes the answer is just one. It kind of depends on sort of like what you're after as far as policy enforcement goes. But it's an awesome question. It's kind of a hard one to answer. All right. So speaking of network policies, I may have accidentally pulled this down when I was editing. I didn't mean to. If so, let's bring this one up because this is pretty cool. Fully qualified domain name network policy operator. Let's see, Josh, get this markdown formatting right. Did I do it? Yeah. Okay, cool. There is a fully qualified FQDN network policy to do fully qualified domain names inside of network policy. Now, this is obviously something that a lot of folks have been wanting for a while, because while it's sometimes adequate to just go out and say, hey, block out to this CIDR or to this label, sometimes when you're egressing, you might want to limit what domain names you can actually enforce against. And we've seen this get implemented in some CNI plugins, namely Cilium, Calico. I don't know if anyone else can think of some of these plugins that have brought like their own CRDs in play to enforce this on their own level. FQDN looks like network policy, so it looks like it's got a pretty similar format. And I'm guessing this probably deploys as a controller of some sort. But nonetheless, this will probably give some level of more native network policy that's perhaps not tied to a specific CNI plugin. That's at least what my first take is kind of looking like. So this would be a super interesting thing to incubate and then maybe make it first class inside of the Kubernetes networking components, right? It's been super funny to kind of watch the progression of network policy enforcement, especially as some of the CNI providers are bringing out replacements for kube proxy, right? We're seeing more and more folks do things like this at like a level of eBPF or otherwise to provide a more fast resolution for some of this stuff. So it's kind of like we've got the CNI providers running ahead in one direction with their own policy models. And then we've got core Kubernetes doing its thing as well. And I wonder if at some point we'll see some level of kind of more universal convergence. In fact, what's funny about this is I'm saying it, I don't know much about Gateway API, but I kind of feel like maybe that's a bit of the story with Gateway API, where we've had these ingress controllers solving different models. We've had Kubernetes services and ingress and its limitations and so on. And perhaps this is an extensible way for us to start thinking about how we're going to map all the different stuff together. So, all right, cool. All right. Ishmael says, as I remember, there's a tool which creates netpols based on Istio CRDs. Yeah, there very much could be if there's something that just translates some of the Istio stuff into lower level network policies. That's totally possible. Alex said, if you don't have a preference, the contour operator would be great just to get some feedback. Sure, we can give it a shot. Sounds good. Michael says, what is Kubernetes? And Michael, I have absolutely no idea. I'm so sorry. But we'll try to figure that out today. Okay, so that's about it for the news. Oh, cool. Also, there's a demo for the Network Policy Working Group that you can check out on YouTube for Network Policy Operator, so you can see how much I butchered that explanation of network policy and take it from there. So cool. I think we're pretty much ready to get started, everyone. So bringing it all back here, we are looking at gateway APIs today, specifically looking at Contour's, really looking at gateway APIs, but using Contour as a way to explore and analyze these. Because like most APIs, or I guess some APIs, right? Network policy as an example. Network policy is great, but without a CNI that enforces it and implements it, right, it won't actually do anything. So same with these gateway APIs. We're going to be exploring them, then using Contour as a thing that kind of executes them. Hey, ABC, glad to see you as always. Maddie says, anyone actually using network policies in production? If so, how do you manage all of those with a bunch of apps? Curious if you have tools that automate that. That's a great question, Maddie. It can get pretty chaotic with network policy. One thing that I've seen quite a bit as a model, not saying that this is the best model, is that namespace scope network policy can be a little tricky and hard to manage over time, especially like if you have some default rules that you need to deny on, and then poke holes in every individual namespace from there. One thing that's helped me out a lot is using CNI providers that offer a cluster scope network policy has been really, really helpful, so that from a networking layer, we can kind of set the baseline of denies, be it like completely locked down or otherwise, and then enable folks to poke holes in each namespace to open up the pieces that they need. But even that can be tricky, right? Because if you just give everybody the ability to put any arbitrary network policy in their own namespace, why wouldn't they just open up all the access, right? So a lot of times that's where some admission control and validation has to kind of come in the acceptance chain of those API objects as they get submitted to clusters. So it's a tricky question. I'm super curious to see how other people solve it. Hey, Chris, great to see you. Let's climb soon. It's snowing in Colorado, so it can't happen out here, but thanks for joining us today. And hope the new gig at Twilio is going well. All right. Gateway APIs with Contour. Let's do this thing. So we have got a link in our show notes. We're actually going to start with the Gateway API docs and maybe talk a little bit about these. And just try to learn a little bit about it. Okay, so this is a project this is from what little I know, a project that comes from the SIG networking community. Its goal is to give us some networking APIs in the Kubernetes ecosystem. So as you probably are very familiar with, where there's some lovely objects we work with daily, services, ingresses, and so on. And I think, a lot of what we're going to look at today is largely coming out from our exploration of these APIs over time and learning a little bit about some of the gaps that they might have in both their ability to do routing rules, and especially the ability to sort of define rules at a higher level that can then be perhaps inherited at lower levels. Kind of like we were talking a bit about with network policy, like how it can be kind of complex when you get to the application developer level where they just care about their singular route in, what settings and configuration should kind of be inherited at that higher level, right? And Chris, I'm not going to ice climb with you. I'm sorry. It's only going to be dry rock. But I appreciate your sentiment with the ice tools. Okay, so let's take a little bit a closer look at these. So some of the things that they're touting. Let's look at the diagram first. So some of the things that we've got going on here. I'm going to draw some stuff as we go as usual. We'll bring in their little picture. Okay, so first things first, it looks like they are targeting different personas inside of here. So infrastructure providers defining a gateway class, which is interesting. The cluster operator defining this construct called a gateway. So I think one thing we'll want to figure out today is what exactly is the relationship between gateway class and gateway. That'll be a really interesting thing. Like you think about class, and my mind goes to things like storage classes, right? That we're used to in Kubernetes, where you can define a storage class, and then you can go in and have a PVC, a persistent volume claim, reference that class, which will then provision the storage. So I'm curious if there's somewhat of a similar model here. So we've got gateways, and then we've got the actual HTTP routes themselves, which are very likely CRDs that are going to have layer 7 rules about path or host evaluation to then route us into specific services, which under the hood typically goes directly to the endpoint IPs of the pods, right? All right, so I think we're looking pretty good. We've got kind of a layout here, some intuition about what might be going on. Some of the things that we're talking about is how can it improve on the current standards of ingress. So more expressive. This has been one of the big things we've hit with ingress constantly, right? Is how do we make something that can be more expressive in things we want to do at layer 7, like header-based matching, traffic weighting, other capabilities. If you've seen a TGI before where I've talked about ingress, you might be familiar with my work on, or I've talked about my work on what used to be the AWS ALB ingress controller. I think now it's just like the AWS controller. Back when I was at CoreOS, we built this out using, and it satisfied ingress APIs. And I remember the first thing that we started doing, which was just hideous, is because the API wasn't expressive enough, we just started letting people fill in all these annotations in the ingress object with rules about how the route would work into the service. And what ended up happening is we ended up having, I'm sad to say it, but we basically like allowed annotations to accept JSON as their value so that we could have more concrete rules injected into the ingress. And it was totally crazy and totally chaotic. So this seems like something that's largely going to solve that. More extensible, role-oriented. It seems like this is probably what they're getting at with role-oriented, where some of these pieces can be inherited in generic. So by generic, this isn't an improvement, but rather something that should stay the same, just as ingress is universal. Gateway APIs are designed to be portable to many implementations. So what this means is today we're going to look at Contour, but in theory, with the spec being specified by SIG networking, we could plug in traffic or any one of the other ingress controllers to sort of satisfy that. So pretty cool stuff. Okay. I think we're ready to try to get started and play around with this a little bit. So one of the first things I was wondering is kind of the difference between the gateway class and gateway. Maybe we could take a quick look at that if the API reference tells us anything. All right, so gateway class. Gateway class describes a class of gateways available to the user creating the gateway resource. Okay, so what kind of stuff do we have inside the gateway class? Looks like we could specify a controller. Okay, so controller is a domain path that indicates the controller that is managing the gateway. So I'm guessing that this is going to be pointed at Contour in our case to ensure that the thing satisfying this specific gateway class is an instance of Contour. So we can try that out. Okay, parameter ref. Parameter ref is a reference to a resource that contains the configuration parameters for the gateway class. Okay, so basically the configuration that we'll be putting in. Okay, so that's gateway class. What's going on with gateway? Gateway represents an instantiation of a service traffic handling infrastructure by binding listeners to a set of IP addresses. Okay, so this probably has a reference to the gateway class somewhere. It looks like it's going to let us put the listeners in place, so probably our IP addresses, or specifically if we're listening on HTTPS or HTTP. That all makes sense. Addresses requested for the gateway. Okay, so this is optional and behavior can depend on the gateway class. Okay, so it looks like we can specify gateway addresses along with some properties of the listener specifically. So perhaps ports and whether ports and protocols, I guess, more or less. Okay, and then there's the reference to the gateway class name. Interesting. All right, seems pretty good. Let's see if we can get this working. So first things first, we've probably got to deploy some of this to a cluster. So I've got a cluster stood up here with some junk I was testing earlier today, but pretty standard cluster. This is just running on one of my hosts inside of my lab at home. And the first thing I think we've got to do is install the APIs, because remember, these aren't new first-class APIs in Kubernetes. It seems the approach they're taking is to go forward with CRDs. And then I'm not really sure how Kubernetes does it nowadays. Like perhaps these will come like first-class supported CRDs, or perhaps there's a potential they could end up in core. I don't really know how some of that's decided nowadays, but something like that. Nonetheless, it's incubating as seemingly a set of CRDs. So this project requires greater than Kubernetes 1.16. Seems reasonable. Let's see if we can get these deployed. All right. So we will just do a quick watch here for get CRDs. Okay. And then I will go ahead and apply down here. And I've been practicing hitting Control L on my keyboard to clear, by the way. So you all might not have to watch me type clear in incorrectly like 20 times in this episode. I've been working really hard on that for you all. You're very welcome. Okay, what do we got going on here? So HTTP routes. Okay, we've got gateways now. We've got gateway classes. That all seems kosher. Okay, so we've got seemingly 3 new APIs. I probably should just double check. So get CRDs for networking. Let's see if there's anything else I was missing in there. A couple APIs. So we've got backend policies, gateway classes, gateways, HTTP routes, TCP routes, TLS routes, and UDP routes. All right. So I talked to some of the Contour folks, and I think I caught wind that specifically HTTP routes are what's working. So it's probably what we'll check out today. Steve says class should give you a configuration of what a gateway should look like. So think of class as your LB specific configurations. Got it. So like internal, external load balancer, things like that. Makes sense. Maddie says it's super cool. Hopefully the Nginx ingress controller won't have hundreds of annotations in the future. Yeah, fingers crossed. Man, we packed a lot of things in annotations in the early days of Kubernetes, but hey, it's kind of all we had, right? I mean, I guess we could have done like a config map or something, but yeah, too complicated. Anyways, I guess a config map would be a slightly different use. So, all right, we've got those installed. Sample gateway. Once you have the CRDs and implementation installed, you're ready to use the gateway API. All right. So it looks like I can set up a gateway class, a gateway, and an HTTP route. Now, Steve gave me a little guide that's Contour specific that I might go to, but I'll tell you what, here's what we'll do to kind of take it step by step. Let's get the Contour instance installed so that we know that that's working. And then we'll see if we can plug some of these bits in to get things routing into it. All right, so Alex had mentioned installing the Contour operator. So let's go ahead and check that out, GitHub. So Contour operator is something that manages instances of Contour. So in the operator model, this should enable us to have something that can manage the lifecycle of Contour, But in a lot of operators, it kind of gives us flexibility through CRDs to instantiate instances of Contour, right? Like a lot of you have probably seen the Prometheus operator, where with CRDs, we can instantiate an instance of Prometheus and it will bootstrap and kind of lifecycle manage that. And I'm guessing there's a similar story here with the Contour one. So let's see if we can do this here. And I think, Steve, you had mentioned that there's a flag that I need to use. Is the Contour operator gonna let me put that flag in to the Contour instances? I don't know if that'll be a problem or not. Let's go ahead and bring this down real quick. So I'll get the Contour operator, and then we'll look inside here. Operator.yaml. Okay, so this will install a Contour operator as expected. Steve says this README should work. Okay, cool. Alpha namespace. Let's see what we got going on here. So there's the CRDs that it's going to bring in. Okay, and just custom resources. Make this a little bit smaller. Here we go. Okay, so all right, lots and lots of custom resources. We'll get past these real quick. See if I can find anything on the deployment itself. Let's see, kind deployment. There we go. All right, so we'll be deploying Contour operator. And then again, remember, this is not the instance of Contour, but more so the thing that's going to make the instances of Contour. And it looks like it's going to use, let's see here, Contour operator, Envoy. Okay. Yeah, let's deploy it. I don't know much about the operator, so we'll check it out. Apply operator.yaml. Okay, and we'll get all that deployed. So with the operator in place, we'll do a quick get pod, see what we got here, and it looks like we've got a Contour operator being instantiated in this Contour operator namespace, so it looks pretty good. Let's watch that real quick, and we are now running. Okay, cool. All right. So we've got that installed. We've got the CRDs in place. Okay, now this is what I was talking about. So when you have the operators instantiated, you typically are going to use CRDs to create instances of the thing. So Contour is not running. The Contour operator is running. To get the instances of Envoy stood up, and then the controller that actually translates, these APIs into Envoy and programs them, we're going to need to set up a Contour custom resource. So let's start by grabbing one of those real quick, and we'll check it out. So we've got this here. Okay. And this will be committed to GitHub too if anybody wants to check it out after the fact. Looks pretty simple. Okay, so an instance of Contour, it looks like we're not doing any specific configuration in the CRD. And when we apply this, the operator should see it and then create our instances of Contour from there. So let's see if we can make that work. Cool. So we will apply Contour YAML. Great. And then let's get pods here again. Okay. Got a little bit bigger. Cool. And now you can see in the bottom, we've got in the project Contour namespace, some new instances of Contour being created. All right. Very, very cool. Guillaume, you said, Chris Nova, when are you back on TGIK? I think we should co-host with Chris as soon as possible. We'll have to talk Joe into it. That'd be really fun. Oh, Chris said the same thing below. Yep, we'll have to talk to Joe and get Chris on soon. All right, cool. So it looks like we've got Contour running. In this case, it looks like these top two are probably the Contour controller, which is again going to be looking at the APIs and then eventually programming Envoy in this case to get the traffic routed into the specific workload. All right, all seems pretty good. So yeah, I guess we could test with Ingress maybe real quick just to make sure from like a bare bones standpoint, things are working before we switch over to the gateway APIs. Just because if something goes wrong with the gateway APIs, it'd be hard to know if things work in the more normal setup. So we'll do that real quick. We'll just do a quick apply of this. Okay, put it in place. Oops, I do not want you in my way, IntelliJ. Okay, cool. Great. So we'll do a kubectl, get pods, and we've got this little default instance that is supposedly being routed to. Let's check this out. It probably just did a standard ingress object in this case. So yeah. All right, so these are the typical ingress objects that we have with Kubernetes. Stuff that's going to let us define layer 7 rules. In fact, let's check out this particular one real quick. So this is that with OYAML, and we'll do a quick less. Okay. So if we look inside of the spec, nothing too crazy. We say, hey, here's the backend service. In this case, it's pointing to this app. Now, it's pointing to the service name. And as we've talked about before in TGIK, the thing to know is like it uses the service almost like as a map lookup or just, I guess, a lookup to what the endpoints are under the hood. It's not necessarily going to route to the service IP and then rely on IP tables to route out. Most ingress controllers are going to read this, understand that this app has 3 instances with 3 endpoint IPs, and then route directly to those pod IPs. So really, we're kind of using the service as a bit of a reference here. And then it's also saying, hey, I want you to do this on port 80 on the back end. All right, cool. All right, so let's see what we've got here then. So we've got that in place. If I do a quick get pods for Contour, let's see here. My instance of Envoy is right here. So if I kubectl get the service for the namespace project Contour for Envoy. Oops, what am I doing? Services inside of project Contour. Okay, Envoy load balancer pending, but it does have a node port set up. So I'm running on vSphere. I don't have metal LB or anything turned on, so I'll probably just try to push through node ports today to see if I can make that work. So if we do a kubectl get pods, or wait, sorry, get nodes. One of my IPs is, oh geez, what are my IP addresses? That would be really helpful to know. Let's figure that out real quick. So if I go to my IPs here, let me just log into my my home lab and get my IPs out. Schrader. Actually, I can see it from the Kubernetes API. What am I doing? So we'll do a kubectl describe node here, just like that. And my IP address should be in here. I think it should be in here. Inside of describe. There it is. 192.168. Marcos, you said O wide. Does that tell me the IP? Probably. You're probably right. Get nodes O wide. Let's see. I'm curious now. That would have done it. Internal IP, external IP. Okay, cool. So let's write some things down because my crazy brain will not remember. So my node IP is this. Let's get the node port again so I don't forget. So kubectl get service namespace project Contour. The node port is 30697. So remember, node ports are ports we open up effectively on every host. And we route into them, and they will balance out, depending on your CNI plugin, probably through IP tables, and eventually get to the workload that underlies them. In this case, that workload is Envoy, right? So in theory, if I curl 192.168.2.201 at 30697, I get some application which might open up in the browser. Let's see. So boom, boom, boom. Hey, there we go. Cool. So step 1 complete. We know nothing about whether the gateway APIs are working, but the good news is Contour is working. So we're routing in through Envoy. Again, in my case, I'm going in through a node port into my host, down into Envoy, and then eventually going down into the application itself. Okay. Steve says that operator guide is more generic, run Contour, but you can reference that Contour CRD from the gateway class. Perfect, Steve. No problem. There's a gateway specific guide on Project Contour. Can put in the notes. Yeah, please put that in the notes. I think if it was the guide you sent me a PR on, I have it in the notes already, but double check. Maybe it's a different guide that you're talking about. And Maddie said, can you use kubectl port forward instead? And Maddie is totally right, and that would be way easier, but for some reason, I like doing it the really, really hard way. I always forget about port forward. You'd be amazed by the insane things I've done with like changing my routing tables and things like that to make this work, when in reality, I could have just used kubectl port forward. The simplest solution is usually the right one, right? But sometimes not for me. Okay, anyways, so we've got that in place. We've gotten this far, and we've got contour set up. So let's do a little bit of cleanup, just because I don't want to mess things up too much. So we applied this example. Let's go ahead and delete this example. And cool, we'll get rid of that. And Chris says, don't use strong -1 to route tables. Yeah, I know, it's not good. Not claiming it's good, okay? I know it's very, very bad. All right, so we've got that good. And now we're gonna try to hook in some of these gateway classes stuff. Some of the gateway class stuff. So Steve, you had mentioned putting something in the show notes. I'm guessing that this was the example that you had sent me. So let me take a quick look at this too and make sure I don't veer too far off here. Okay, so gateway class, gateway routes. We've got contour deployed. Well, this is the CRDs for the gateway APIs. We've got that. Deploy contour, we're doing the operator. So fingers crossed that doesn't cause us any pain. And then there are some sample resources for common and for the gateway itself. So let's see if we can figure some of these bits out. Right, we'll look at the common one first. All right, so we'll wget that. Okay, look at O1 common. Maybe what the heck did it just call it? What happened? Wget 404. Why do you hate me? Okay. Use option 2 for the operator. Thanks, Steve. See, you're already saving me from going down a crazy path. And I was getting a 404 anyway. So using a load balance service, using a node port service. Okay, cool. Let's look at the gateway configuration for the node port piece. So we'll go ahead and wget that. Okay, that one gave me a 200. So gateway. Okay, what do we got going on? So namespace is here, namespace, project contour. Okay, so in this case, it's setting up some extra configuration for us inside of the contour CRD. So it looks like the contour CRD is referencing a gateway class that we're eventually going to deploy up, and giving some details about node port service. So we'll check this out in a moment. I'll delete my other CRD, but my guess is that this is probably going to, right now we're using like cluster IP to node port to load balancer. And since I don't have a load balancer hooked up, it'll probably just stop me here and expose it as a node port. Okay. So gateway class, let's see what we've got going on here. Okay, cool. So this is what we were looking for. It looks like there's references in both directions, I suppose, right? There's a reference on the controller, which is probably telling Contour, just like you would tell a CSI driver or something, like, hey, this is the storage class or the gateway class you care about. Like, this is yours to satisfy, right? And then to some degree on the API for a gateway class, it looks like we also reference what controller actually satisfies this. Now, I wonder, I don't know if you know offhand, Steve, or anyone from the Contour team, but like, does this specification on the gateway class have like a functional purpose? Like, is it doing anything to like scope itself in a weird way? I would assume not. Like, I would think any controller could see this gateway class with the right permissions. I don't know if this is more of a piece of metadata or if it has like functional purpose. And then some of the parameter stuff. So as we had mentioned, there's this idea of parameters in the API. So let's go back to that real quick. API types, gateway class. Okay. Let's see here. API reference, Go docs for the package. We'll see if we can see it here. So we've got the gateway class right here. Okay, and then inside of the gateway class, we've got the spec and then the parameters ref inside of here, which looks like it's giving us the ability to reference, in this case, some of these different fields in here. So group, kind, scope, name, and namespace. So maybe this is where it's actually scoping somehow what the kind of functional purpose would be for satisfying this CRD. I'm not really sure, but the scope specifies that it's going to be namespace scoped, probably rather than cluster scoped. Let's see if it says that in here. Namespace is a field. This field is required scope to set namespace and ignored when the scope is set to cluster. Okay. Scope represents if the referent is a cluster or namespace scope resource, the name, the kind, and the group. Okay. Let's see. Steve says, supposed to tell the controller that it should manage that gateway. Contour watches a single gateway at the moment. Okay, got it, got it. Cool. All right. Cool. So we've got a gateway class, we've got a contour instance. Oh, and it looks like they've got a sample gateway in here as well. So maybe we'll bring the sample gateway out and bring that in as a second step just for the heck of it. So let's do the actual gateway itself here. I'll put that, I'll put that right here. Cool, we'll go ahead and save that up. Gateway node port YAML, looks good. Okay, so what do we got going on here? So, okay, get contour. We've got a sample contour. Let's get rid of this one just to make sure it doesn't mess us up. So we'll delete the CRD contour, the instance of that contour sample. Okay, and then if we watch our pods one more time, we should see that the contour instance is terminating. And what I'm gonna do is bring in this new CRD from the guide we've got and instantiate another instance of contour here. Okay, almost there. Terminating. And then Steve says the parameter ref in the gateway class references the contour operator specific CRD for the contour specific configuration. Got it. So I guess, Steve, that's probably what makes it pluggable per implementation, right? Wherein what you would point to on in traffic might be different depending on what things that they expose in that CRD, or in that configuration, I should say. So cool, we've got the contour operator. All right, let's get this thing deployed then. So we're going to apply the gateway node port here. All right, and then we will watch some pods. We've got another instance of contour bootstrapping up and an instance of Envoy getting set up as well. Seems pretty good. Okay, so let's see if we can get back to this guide here. Okay, node port's in place. Looks like I'm going to be redeploying the same sample app again as well. So I'll just go ahead and step ahead and just deploy this piece real quick. So we'll get rid of that. We'll do a quick apply. Cool. And then let's watch pods one more time here. Make sure that our sample app gets spun up here. Some ref error on apply. Let's see. It's missing the value. Resources for create. Yeah, that I think this is just telling me that I should have used a different command. Yes, and Marco said you removed the gateway. Yes, I do still have the gateway removed, so we'll bring that back in a second. Am I missing my my app? Am I going? Oh no, it's at the bottom there. Okay, we're good. So we've got the app running in the project contour namespace. I haven't put the gateway in place, so let's go ahead and let's take a quick look at the gateway and then bring that in real quick. So, Josh, did you not save the gateway YAML? I think you might not have. How the heck did you do that? Okay, no big deal. Let's go ahead and get the gateway node port one more time, and we'll just look inside of that. So gateway node port YAML, and then here's the gateway class that we've got specified. And oh, you know what? It brought it down as a second one. 1.yaml. There we go. Okay, sorry. Hang tight. Here we go. 1 YAML. We're going to move gateway node port YAML 1 to gateway node port YAML. There we go. Okay, back at it. Gateway node port. All right, so here's the gateway that I had gotten rid of before. So gateway has seemingly some configuration inside of it that is going to specify, as we had learned, our listeners, right? Okay. And the listeners are routing in or specifying the protocol in the port, like we talked about earlier. So taking HTTPS if available through 443, and then HTTP. And then the only thing that I don't understand, and maybe we'll figure this out in a moment, is why are the routes defined here? That seems really weird, right? Am I losing my mind, or are the route objects and the gateway objects separate things, right? Because I had imagined them as HTTP routes that reference the gateway object, but maybe I'm losing my mind here. Is the gateway object one thing that also defines the route itself? I don't know. Let's see if we can figure this out. I'm sure it'll tell us a little bit later. So I'll do a quick apply for the gateway node port again. Cool. Okay. And then we'll do a watch, which I think from a pod perspective, probably nothing's going to change here. We've still got this in place. I would imagine it is programming Envoy to some extent. And it looks like, it redeployed the controllers as well. I wonder if that was something that I mucked with. We'll give it a second here. All right. Cool. So is it routable now? That's what I'm not too sure about. So testing the API gateway, or testing the gateway API. We've got the quick start started. We can probably figure out how to route into it. So let's go ahead and see if we can do that again. If we do a kubectl namespace project contour for services, we've got the Envoy node port at 30080. And then if we just grab this over here, the IP address, we'll snag that real quick. Okay, and we'll do another curl for this IP at 30080. Okay, and nothing's coming back. So what was the route that I set up in there? The route was matching this on HTTP on port 80. Interesting. Okay. All right. So Steve says gateways need to select which routes that a gateway can process. Interesting. Alex says gateway and HTTP route will reference each other. Needs bidirectional bind for it to work. It seems really weird to my brain. I can't understand why that would be necessary, but I must be missing something. Okay, so we've got this in place, and I'll go back to the guide here. Let's see. So we've got the node port service set up, right? We created project contour. We created a sample application right here. Okay, now verify that the resources are available. Okay, I think we've got these available. Let's double check here. So, yep, those all look healthy, are running. There's a service fronting them. And then there's the HTTP route got brought in with the app, it looks like. Okay, so I missed that little detail. Let's check this out real quick. So inside of here, it looks like we're maybe specifying an HTTP route. I assumed it was just deploying the application. So we'll grab that and we'll see if there's an HTTP. There it is, HTTP route. Okay, cool. Okay, this is kind of this makes more sense. So this is what I was expecting from like a routing rule perspective. I'm still a little confused. Oh, this is probably why it didn't route, by the way. It's specifying a host name here. So I can just mock the host name and trick it. So the HTTP route, this makes sense to me. I still don't grok the relationship with the gateway specifying the route though for some reason. Let's see if we can get this to work real quick, and then we'll brainstorm as to how exactly this is working. So I'm guessing it probably just needs this host name, which is totally fair if that's the case. So we'll grab that. We'll do the curl again, wherever the curl was. Curl this, and let's see if I can remember my curl stuff. Host name? No, not what I wanted. Okay, curl h hostname local.project contour.io. Oh geez, Josh, come on. There we go. We got this. We're gonna find our way through this. Okay, there we go. We've got 92192. Do I have my headers right? Hostname. Let's see. Gateway, JSON path, host name. Oh, host. Jeez. It's Friday, everybody. It's Friday. cut me some slack. There we go. That looks a lot better. Okay, so now we're hitting it with the right host header. Yeah, Marcos. Yeah, you're exactly right. Okay, let me read what you all are saying in chat here, because you're probably trying to explain to me why. So let me bring up where I'm confused. Why does, let's get rid of this and this. Let's do a quick split, and let's look at gateway node port. Okay, here's what I'm confused about. In the bottom here, I've got the gateway, and it specifies listeners with the routes. And then these seem to reference or be implied to reference this particular route. So why do both of these need to exist? Okay, so looking at the bottom one here, the gateway is matching the app, it looks like, right? So the gateway is actually saying, I'm going to resolve the HTTP route against this specific app. And then okay, I think I'm starting to grok it. So it's decoupled in the sense that like this is actually going to have the rules about, oh no, it says forward to. It's still resolving against the service name. What the heck? Okay, I'll read chat before I drive you all crazy. Marco says the route in the gateway is not the definition, but just a reference to that HTTP route. That's what I'm thinking. Steve says multiple gateways can select the same routes. Interesting. Okay. The example has label selectors to find which. Okay. This is where I'm getting confused. So what you're saying here, Steve, is that the selector right here, the selector is actually selecting the route object. Does that make sense, everyone? So where I was getting confused is I was like, well, why the hell is the gateway selecting the app service? Because wouldn't the route do that? And the route seems to do that right here. But in reality, I think if I'm grokking what Steve's saying is you can have multiple routes resolve against the gateway. Maybe I'm saying that wrong, but effectively this selector here is selecting against this specific HTTP route that is set right here. That seems to be the relationship. I'm still trying to work through in my head what the value add is with that. So if I have another HTTP route that resolves against this service, I could tie it to a different gateway, I guess, which would be kind of interesting on a unique path and things like that. Interesting. Okay. Dennis said the gateway class has a reference to HTTP routes, but it's not a list. So there's a one-to-one relation, single gateway. Yeah, I wonder, Dennis, if the label matching, I don't know if the label matching could be used generically enough to match against two routes that share the same label, perhaps. Yeah, it's interesting. It's kind of hard to wrap my head around, honestly. Okay, so let's see if we can map this out, and if I just make it more confusing, then I'll just give up. Okay, so we've got from an API standpoint, right? And we'll keep their diagram around here too, right? So from an API standpoint, we know that there is the ingress class piece, right? Ingress class, okay. And we know that the gateway class, all right? We know that the gateway class defines some configuration and specifies a reference to a gateway. So here's our gateway class, right? And we know that the gateway class references this specific controller. And we know that it's looking at specifically the contour configuration and where it can find that contour configuration. So it references the contour gateway sample contour operator, which we can see down here is the contour sample gateway. And then down here, wait, where did my gateway go? Gateway. Gateway name is contour namespace contour operator. Interesting. Huh, that mapping doesn't make sense to me. Okay, so anyways, going off of their diagram here. Oops, what the heck just happened? There we go. Going off of their diagram, we've got the gateway class. We've got the gateway itself. Okay. All right, and this seems to have a mapping into the gateway somehow. Okay, gateway class is mapping into the gateway. So parameter ref is looking at operator contour namespace, contour operator. Okay. Cool. So let's see here. Okay. Alex says he has to hop out. Thanks for joining us today, Alex. Appreciate it. Okay. Alex says the HTTP route mirrors Contour's existing HTTP proxy virtual host stanza, essentially. It's application routing. The gateway has a bunch more stuff in it. It represents the load balancer config. So multiple contours deployed can reference the same route resource, I believe. Although not sure if that's been tested. Okay, interesting. All right, so we've got the gateway, and then basically, I guess really based on their diagram, I guess I'm kind of recreating it here. We can have multiple HTTP routes that reference that same gateway, or it can be, I guess I should say, can be selected by that same gateway. So maybe we'll try that out to see if we can kind of prove this out and understand it a little bit better. So in theory, I can have this HTTP route that goes down to this app that we're using, right? And then I can have maybe another HTTP route that goes down to the same app, I guess, in a way, if it's routed against the same service name. But maybe this one is saying something like, hello there. And the listener maybe could be configured to do something different. And this one is obviously just routing against /. And they could have different listener declarations. So like what protocols and ports they're listening on, I suppose, could be unique. So let's see if I can make that work just for the hell of it. So we'll go into here real quick and let's look at the sample app, which has this HTTP route real quick. All right, so we will do a gateway2.yaml here. Okay. Great, we've got that. Okay, cool. So I guess, okay, so in theory, like when we think about how the selection works, if I screw with this and I say foo, right? And I put this in place with a different header. Let's say the header, we'll make the header unique maybe. Oh no, same header, and then we'll do a value of, what did I say? Hello there. Okay, hello there, cool. So that's the prefix, and then it's gonna route into this same app. Now, if I'm understanding the relationship of how this all resolves, I think this shouldn't get picked up because the HTTP route set up in the gateway doesn't have a selector. Oops, I'm looking in the wrong file here. Let's go back to the gateway node port. Because the selector inside of here is only matching against things that that have this app label. So in theory, this would probably be like an orphaned HTTP route that doesn't actually get satisfied by the ingress controller. That's kind of my thinking in this new model. I'm trying to tease it apart here a little bit. So if we just apply, what the heck? If we just apply gateway 2, so kubectl, apply gateway 2. Okay. Oh, Josh, why did you just do that? You didn't change the name. Not good. Gateway 2. Okay, we're gonna go back. So 2. All right, let's apply this again. So apply the example. Yep. Okay. Dennis says, with the current setup, the second test will return the first HTTP route prefix matching. Let's see. Okay, so I will apply again route 2. Okay. Apply gateway 2, which is really an HTTP route. Okay, cool. So now inside of default, I've got 2 HTTP routes, I'm pretty sure. Or I've got them somewhere inside of Project Contour. Okay. So inside of project contour, we've got 2 routes, same host name, one's on a different path. Now, my theory here with the selection is, again, this gateway is using label selection to determine which routes it should satisfy. And then the gateway is tied to the gateway class, which is tied to the ingress controller that should satisfy it. So I think I'm definitely not grokking all the implications, but I think we might be starting to get somewhere with how this all resolves. So if this theory is correct, if we curl back to our original address, this still works just fine, right? So that's all good. Now, the other one was on a / though, wasn't it? Okay, let's play it safe real quick. We're gonna go back to the example and change this to goodbye, okay? And then let's apply this here. So kubectl, apply this app again. All right, cool. So let's hit that. Doesn't work. That's what we'd expect. But if we go to goodbye now, does it work? Uh-oh. Why does it not work? Goodbye. Huh. Is that what needs to happen? Let's see. Apply. Uh-oh. Huh. Oh, right. The app doesn't have a path for that, duh. And I'm not doing URL rewriting here. Yeah, that makes sense. Darn it. Hostname will work, right? I can do hostname. I should have started with that. I didn't even think about not doing, I didn't even think that I'm not doing path rewrites here. Okay, so let's go with hostname. /. This will be test1. Test1. Okay, and then this one over here this will drive me crazy. It's not a gateway. Gateway 2 should actually be called http route2.yaml. Okay, so we'll do http route2.yaml. We'll call this TGIK, and then we will get rid of all this junk here. Cool. Let me check that out one more time. That all looks good. Okay, so we've got test1, we've got TGIK. So will this work? Now that I'm realizing that I'm not just rewriting the path at the ingress level, but I was actually passing that path down to the app. Let's see. So we'll do a curl again. This obviously won't work. But I mean, we were getting a 404, so if the 404 was coming from the app, then that's a good sign. Local doesn't work. That's good. And then, wow, Josh, did you already forget? What did I call it, everyone? Was it test? Oh, geez. I need to write things down. It was test1, of course. Because why just call it test? You might as well put a number at the end, you know, just in case. That doesn't work either. Darn it. You can swap card kard out for which shows path echo server TGIK. Why does my host not work? What did I do? Did I screw up? Don't want to change too much on you though. Yeah, I hear you, Steve. I think the host should work. What did I do? Did I do something stupid? Did I redeploy the app and change the if it was the node port that was broken now, I would think it wouldn't let me route at all. So interesting. Okay. So get service, and then the service name here for Envoy is this. It's 30080. Okay, so that still works okay. Okay. The changed label selector for the gateway, Dennis says. I don't think I changed the label selector on the gateway. So this is still the original route. And then if we look at the gateway real quick, let's open that up. So if we open up the gateway, which was in gateway node port, it's still selecting against that route. Huh. Interesting. What the heck is going on? Okay, I'll tell you what. Here's what we should try, because I think we're really close to figuring out how all this mapping works. I'm going to redeploy the sample app again, make sure I can route to it. Then we'll change the host name and make sure that doesn't break anything. And then we'll try to introduce another HTTP route to show how this resolution works. Khosrow, you said, did you apply the recent changes. I think I did, but now that you're saying that, I have no idea. So let's just try it again. Okay, so here's what we're gonna do. Let's go back to the example and let's grab this one more time. And I'm even gonna be so careful that I'm gonna just go ahead and bring this file down again. Okay, and then we're gonna move this into what this is now, okay? We're going to delete F, probably something I should have done before. Get rid of all that. We will delete F, the gate HTTP route 2. Yeah, great. All right, let's try to wire this all back up again one more time. So inside of this, I'm gonna bring the HTTP route out, okay? And we're gonna put this inside of HTTP route 1.yaml. We'll put we'll put this right here. Okay, so now we've got HTTP route 1, and then eventually we'll have HTTP route 2, and we're gonna redeploy the entire app stack on top of that. So if we do a kubectl get HTTP routes, nothing. We're starting fresh here, right? So we'll apply the app. Cool. Cool. Oh, and Ilko, you said you can use paths like Ready API. Okay, cool. So that it has some extra endpoints. We can check that out too. Or not endpoints, but paths that it can resolve against. Okay, so we've got that applied. Get pods A. Okay, it is running. Lovely. So now if we apply HTTP route 1, does everything work the way it used to work? So we will do a kubectl get service. Let's just do it for all. Make this smaller. Envoy has not changed its node port, which is good. So in theory, if I curl against whatever the original one was, local, do we get a page back? Thank goodness. Okay, we are in a known good state. That's the important thing here. So now that we're in this known good state and this works, let's just change the host name of the HTTP route and make sure that's all cool. So we'll go ahead and do this. Oops, sorry, of HTTP route 1. And we're just gonna change this to say, hello, TGIK. Great, and we will go ahead and apply this. It has been configured. Okay. So now, check me here, everyone, if I screw this up, but hello, TGIK. Lovely, okay. Who knows what the heck I screwed up last time, but now local should not work, great. And then hello, TGIK should work. Lovely. Now, to remind you of the point we were at before that all happened, it seems like as we're starting to tease out the relationship, this thing is resolving what controller and what configuration to reference. This thing is providing then selection into which HTTP routes it's willing to satisfy based on a label selector. So in short, if we take one more look at the HTTP route 2 here, I change the label to foo. So in theory, I think that this HTTP route right here, number 2, which is now just TGIK dot, right? This should not work because the label selection from gateway should not come down, and thus the route to this should not be satisfied from the ingress controller. Because remember, what's really happening here is like the cascading of these APIs and the selection of these things is at the end of the day something that the contour controller is picking up and then programming Envoy to set up the routing rules. So in effect, by this relationship not being here, I'd imagine there's not going to be a route that contour then programs Envoy to route into for TGIK. But let's see if that theory holds true. So we've got labels foo here. We'll go ahead and bring it over and we will apply HTTP route 2.yaml. Okay. And then if we curl again for hello TGIK, this seems to work great. Now, if we do just TGIK, does not work. So far our theory is correct. But to rewire this back up then, if we just either, I mean, I guess we could change the gateway selector in here, which I don't think the gateway selector took an array, which is what, was it Who said that earlier? Was it Dennis that said that? Somebody had said it in chat. I don't think the gateway takes an array. So I think the label probably needs to be the same on both of the objects. But let's just double check that real quick. So gateway, node port, cool. So routes, HTTP route. So this lets us select the actual kind. So these would also be pluggable. It would appear at least, which is great. So like if we have a different API we want to use here maybe. And then the selector is going down to this label, and I don't see it as, well, could I do this though? I mean, the whole thing is technically an array, right? Can I do this and say, what did I put? Did I put foo? I wonder if that'll work. I'm probably changing too much now. But let's see. Just, well, would it be allowed to have 2 listeners on the same port? Is that just like a meta concept that it'll know? Okay, sorry, I'm jumping the gun here. We're not going to take this much risk just yet. Let's keep that commented out, and let's just make sure that if we go in and change HTTP route 2 to say this instead, that it will route into itself. So we'll apply HTTP route 2. Great. And now if we curl into just TGIK, which is our second one, there we go. So now, because of that selection, it knows, hey, I want to go in and I want to resolve, okay? I want to resolve routes that use this kind of object. So this particular CRD, which is another way that this, in theory, could be extensible and pluggable. And I only want to resolve route objects that match this label. So I think this is actually starting to make a lot of sense in regards to how it could be extensible as we go in and reference certain APIs and what they resolve against. And then remember, since this is then tied to the gateway class, which then is tied to the ingress controller, we've now got this full-on relationship. Now, I'm not gonna, I guess we could try it, but like in theory, you might even be able to do something like this. I don't know, like it seems like you could plug in a different kind perhaps. I don't really know if that would work, but I'm curious if this will work. If we did HTTP as an array here, I wonder if this is like a meta thing that it will just kind of know that this is not a problem. But no, let's try it. Who cares? So we'll say that this is foo. Let's go ahead and apply this again. So, I really want to take that out actually. Gateway node port. Let's grab this real quick. So we'll take this whole chunk out. Okay, and then we'll call this gateway config.yaml, right? And then we'll paste that in. Great. Perfect. All right, cool. So get rid of that. Kubectl apply gateway config.yaml. Okay, contour configured. So now, if all goes well with this gateway configuration we've got, in theory, I could match against labels foo, I suppose, for any of the HTTP route objects and then put it up against port 80. Now, how it would handle conflicts and stuff if there were 2 HTTP routes with the same rules and stuff, I have no idea how that would work. I guess that's something maybe on the ingress controller's responsibilities to resolve if there are conflicts against 2 things that it selects and resolves against. I have no idea. But anyways, seems like we've got that in place. If we go back to HTTP route 2 here, and then we change this to say foo, I wonder if this will work. So we will go ahead and apply this HTTP route. It's been configured. And then if we curl against, okay, so this one, we'll start with hello TGIK, just to make sure I didn't blow anything up. All right, so hello TGIK is seemingly still healthy. Now, if we go in and do TGIK, does it select against that? It does. Okay, so in short, we were able to make multiple selections inside of here against potentially multiple label sets for the HTTP routes that we want to use. And, this will probably be honestly not too uncommon of a configuration where, maybe there are multiple labels we want to include in here, but we still want both of them to resolve against port 80 when it comes in, right? So that could be a common thing. All right. I kind of think this is starting to make a little bit more sense. What do you all think? Is it more confusing, less confusing? So it seems like, in short, we've got, again, the gateway class. Okay, we'll go API by API real quick. So we've got the gateway class here, which is gateway node port. Okay, we'll look at this first. All right, so what do we know about the gateway class? Well, the gateway class ties itself to a controller, it would seem. So in this case, we're resolving ourselves against this, this contour operator contour gateway sample. So if we look at this in kind of like a really quick thing, so namespace contour operator, get pods in the namespace contour operator. Okay, so we've got the contour operator. What are the actual pod names actually, now that I think about it? Contour cert manager, where's the contour controller? Oh, there it is right there. Okay, so project contour. All right, cool. So we're resolving it against contour operator. Contour gateway sample as the name. I think this is maybe one part that I don't quite understand. What, the name of what? Because it doesn't seem to be the contour instance, and it doesn't seem to be obviously like the contour operator. So I'm not quite sure what the name is referring to, but it says kind contour. So is it actually referencing the CRD? Is it that simple? Get contour in namespace contour operator. Let's see. Oh, okay. That's okay. Cool. Oh, and then gateway class admitted. Okay, great. The relationship's starting to make sense. So sorry, it's the operator model in this gateway thing that's really kind of racking my brain here. Okay, so what do we know? We know that the gateway class is attaching itself to an instance of contour, which in the case of the operator, it would make sense for it to be a CRD because the contour operator is not an instance of contour. The contour CRDs that it will then satisfy is what's going to represent these instances of contour. So we've got the contour CRD here, and this is referencing it and scoping it. And then this, in short, kind of references many instances, one or many instances of contour, right? Contour. And then we know the thing about contour is when contour is instantiated, the underlying proxy is Envoy, right? And effectively, what we know is that contour goes into Envoy's little brain and it's like, hey, I know all these things about the Kubernetes like APIs, like here's how you're gonna work. And then Envoy's like, cool, like I actually know how to send traffic into this particular application. Now, as we go layers down in the selection, we know that the gateway will reference a specific gateway class. So let's go back up to that and see if we can bring this full circle. So we know that the gateway configuration, whatever I saved it as, which is gateway config.yaml, okay? We know that the gateway configuration references the gateway class, and then these two are sort of bound together. So if we do get gateway, right? Here you can see that relationship one up. So gateway, the gateway class is attached to this contour operator. The gateway is attached to the gateway class. So it has that resolution and that tie right there. So as the gateway then selects routes, those will belong to this instance of contour, which is starting to sort of make sense. So we've got the gateway in place, and then as we've played with, we can set up many listeners that will specify the protocol, the port, and then the potential APIs we want to resolve against. So like I said, no idea like what's pluggable here, if you can even do something like this. But in this case, it's saying, hey, any instances of HTTP route that resolve with this label selector, I'm going to satisfy those inside of the contour, which I'm attached to through my gateway class. So then we go into the actual HTTP routes themselves that the gateway is looking to select on. And as long as one of them is selecting on this name, right? And then in this case, one of them is selecting on this name, these two HTTP routes that a developer will put in will then be able to be resolved by this instance of Envoy. And the second we screw around and do something like TGGIK, right, we then break that link away because the gateway is, I guess I should probably break the link on this end, right? Because the gateway is not selecting on that. So since that relationship's not there, Envoy is not going to get configured with that lower level application routing, right? I think that is what's going on here. So Contour team and others, you can tell me if that definition is wrong. It's probably still a little bit spacey and chaotic, but that is very roughly what I think we've got going on here. And if you take a moment and really think about this kind of inheritance model and the selection and references, it's going to give us the level of pluggability that I think Ingress has needed for such a long amount of time. And the pluggability will give us a ton of different ways to have certain ingress controllers that can perhaps satisfy certain configurations and thus have certain types of load balancing. But also, that aside, just the ability as like a platform operator to be able to go in and basically set up this higher level gateway construct where we can then perhaps let developers self-service their own HTTP routes. And as long as they match the label that goes against the gateway, I would imagine that whatever the proxy is, it should be able to eat it up and shoot the configuration into that ingress controller proxy that underlies it, and then the routing will just work. So we've got something that's extremely extensible and pluggable. And we've also got something that really hones in on these different operational models that we have in most organizations. Especially in big shops, it's pretty darn rare that the developers that run the app in Kubernetes own the stack from top to bottom, especially in like these multi-tenant systems. So a lot of times, or even just multi-team systems, a lot of times you need inheritance constructs like this to enable there to be a singular API level that you can hand off to developer folks and really let them kind of plug into it. Okay. Whew. So Steve says, that's about right. It's way more configurable. I totally believe it, Steve. There's probably a lot more in here that you can mess with and tune with. But hopefully this gives you all a pretty good introduction to kind of how some of these resources work together. And at least for me, I definitely understand a little bit more about how all these kind of APIs link together, because before it was at the initial onset, it was a little confusing for me. I'm not going to lie. So yeah, overall, pretty cool stuff. It'll be super interesting. I mean, Steve can tell us more, but to see how this API develops further, how quickly Contour will actually go in and implement a lot of these pieces. And, aside from the APIs being new and everyone giving feedback and all that stuff, there's obviously going to be some amount of runway where all the ingress controllers are slowly going to have to, re-platform into this model, I guess, in a way, or at least just comply with it so that they can resolve a lot of these new APIs that we're sort of looking at right now. So very, very cool. Yep, and Yusuf, you said ingress route and traffic kind of looks like HTTP route. Yep, and I think that's probably what blew up a lot of this need, right? Is just you had traffic making their own CRD. We had Contour having their own CRD. And it was largely to solve kind of problems like this. So it'll be really interesting. It'll be a good test to see, does this new model give us the extensibility to be generic enough, while also giving the pluggability to be specific enough when it comes down to some of the rules and capabilities of different load balancers? Because all load balancers, or proxies really, aren't made equal, right? A lot of them have extremely different features that then merit or demand their own specific configuration and stuff like that. So pretty cool stuff. Okay, well, this was really fun. I'm going to be sure to put the diagram and all the crazy YAML files that I've played with, if anyone's watching this, in the GitHub repo in case you wanna play around. But as always, thanks so much for hanging out, everyone. Steve gave some resources for where we can give feedback. Steve, thanks so much. And Alex and the other folks from the Contour team, thank you so much for hanging out today and answering questions. Really, really appreciate it. I hope you all learned something today. I know I definitely did. And have an awesome weekend, everyone. Hope you spend some time away from your computers and do some cool stuff. All right. Thanks, everybody. Have an awesome weekend, and we will catch you next week with what I'm sure will be a super, super interesting topic. All right, all. Catch you next week. Later.